All right, thank you, folks. It's a real honor to be here at the NASA booth again. I got a presentation I hope you'll find exciting, interesting, in both a retrospective and a future-looking way. I'm pleased to represent a really excellent team of people, starting with Jake Bleacher and Ben Feist, who've been working with a team of scientists as part of a survey group through RISE, as well as a group based out of JSC, Scythe, and Goddard's instrument field team, GIFT. And part of these collaborations are facilitated by Kelsey Young, who splits her time between Goddard and JSC. And so this is a collaborative effort to basically help prepare for future human exploration of any body in the solar system. We're going to talk about the moon, particularly, and some field work that have been done in preparing to think about how we're actually conduct this field work and how we're going to collect the data and analyze it and archive it in a really appropriate manner. I hope everybody was aware that we're in the midst of, oh, next slide, please. Sorry. Yeah, we're in the midst of celebrating the 45th anniversary of Apollo 17. 45 years ago at this moment, the Apollo 17 crew is still sleeping on the surface of the moon, preparing to lift off from the Valley of Taurus Littrow later today. Apollo is an incredible technological and human achievement. They enabled humans to explore in situ areas on the lunar surface, again, 45 plus years ago. One of the great achievements of Apollo is that not only did the astronauts get to go, but we all got to go with them in the form of either video transmissions, the few times that those occurred, or audio transmissions from the lunar surface. And when you listen to the astronauts' voices, and particularly on Apollo 17, Jack Schmidt's voice, where he's describing, he's conducting his field geology, he's writing his field notes with his voice, it really provides a rich context for what they're actually doing on the surface. And of course, they photographed the lunar surface in great detail, including all of the samples that they collected while they were there. They left experiments in the form of the Apollo Lunar Surface Experiment Package, and obviously debriefed and reported on what they had seen. So there's this incredible treasure trove of not only samples, of course, but their voices, their pictures, and the data that they returned and continued to return through ALSEP. Now, as a lunar scientist, and as anybody here who's tried to work with Apollo data, you can go to the curation website and get information about samples. You can go to Apollo Lunar Surface Journal and get the voice transmissions. You can go to various places to get the photos. You got an incredible archive of material, but it's scattered. Different formats, different places. One of the most compelling objects, apart from the astronauts themselves that came back from the surface, is the thousands of photos that they took while they were on the surface. The expression is a picture is worth 10,000 words. But how many words are unsaid where the photos aren't analyzed or the data is just sort of disparate and not easily accessible? And so what we're starting to think about is how to put all of the work that was done both back in Apollo, but also that remains to be done in future exploration in a context. As a geologist, we're all agreed that context is the most important thing for any sample. Knowing where it came from is the difference between a nice souvenir and a scientifically valuable rock. And so we want to go back and look at these scientifically valuable rocks that were collected in their context, as well as what we can do in the future. Actually, can you go back for 1 second? This is one of the most beautiful images taken on all of Apollo 17 at Station 6. And just to point out that here's Harrison Schmitt, the only geologist to walk on the surface of the moon. Here's Station 6 Boulder, and there's the lunar module sitting on the surface many kilometers away. Next slide, please. So as an Apollo junkie, self-professed Apollo junkie, there's an amazing website, apollo17.org. Everybody should connect their devices, laptops to the wireless here and crash Ben Feist's server. He's serving this from his home. It's an archive of the entire mission from launch to splashdown as it unfolded in real time. And what Ben has done is collect the video, the photos, the transcript, and placed it in a time context. So we have everything as it unfolded in real time. For example, this is the astronauts approaching Station 4. He's used Apollo Lunar Reconnaissance Orbiter DTM data to recreate the traverse. So we see the astronauts coming up to the rim of Shorty Crater. You hear them describing what they're seeing. You hear Jack's voice describing the discovery of the orange soil. And again, placing those samples not just into a context, but then being able to say, here, he describes sampling bag 509, which is the famous orange soil. We can link to all that information and basically putting those samples, which are some of the most important that are returned from the moon, into the context of the moment they were collected. And so being able to understand the rocks now, not only their scientific importance, but what was going on when they were collected, what was Jack saying, what was Gene saying when he sampled them, and what was the spatial context of where those rocks came from. This gives these rocks, these samples, an incredibly new and vibrant life. Being able to understand exactly what was going on, where they came from, puts them into a fourth dimension, the location on the surface and the time they were collected. And that value really, I think, augments our understanding of what was done, again, 45 years ago now. Let's go to the next slide. So in looking towards the future, this is an example of some of the infrastructure, the test units that were developed for practicing for future human exploration. This includes multiple rovers, habitats, facilities to get humans further distances on the lunar surface and increase their capabilities while they're on the surface of the moon and eventually onto Mars. You know, the support, the facility behind this is going to tremendously improve upon what was done in Apollo in terms of documentation. We're going to have cameras recording everything that goes on. Every structure support will have a camera on it. So this is going to be an incredibly detailed and valuable archive of material. Now, you may not know at that moment that you want a camera that's pointing aft of the rover. But I guarantee you, as a scientist, 5 years from now, we'll want to know something happened back there or see something. So having all of this information that's collected either in test scenarios or actually in situ is going to really improve our capabilities of understanding what was going on. This high volume of data may be not only useful for planning at that moment, but also the subsequent analysis, the science analysis of what was going on, what was collected on the surface. Let's go to the next slide. And so this takes us to a field test that's been conducted as part of the survey work. This past summer, a team of scientists went out to the Petro volcanic field in southern New Mexico to basically test how handheld instruments will be used and can be used in the field for astronaut training and for future exploration. And so a team of scientists and engineers went out into the field to study the Petro volcanic field, but also simulate an exploration. So we had a simulated crew of 2 astronauts, indicated here. We have a journalist as part of the RISE effort to document what was going on. We also had instruments, a LIBS instrument and a handheld XRF instrument, which were analyzing samples in situ. Here's a beautiful basalt bomb sagging through some of the volcanic deposits. And so this really rich geologic environment provided a perfect opportunity to test not only the use of the handheld instruments and how they can be incorporated into surface operations, but also this idea of collecting data in real time so that we can place all of the information that's collected into this, as I call it, this 4-dimensional architecture. Where the samples were collected, when they were sampled, what is the crew looking at when they do it. So this next slide, please. And so this is a simulation led by Ben Feist that is gathering that data. And so I want to describe a little bit of what you're seeing. These red dots are the different stations that the crew identified. We've got GPS locations for the 2 crew members, Liz and Butch, and a little bit of a trace of where they're walking. And so you'll see them moving around as the data is collected. On the bottom, we've got the chest-mounted GoPro cameras that are recording what they're looking at, and they're also what they're saying. We've got a camera that was used by Butch to record what's going on. And then on the right-hand side there, drone footage that was captured during the test, flying over the expedition. Actually, the GoPro footage, the drone footage was then mosaicked on top of some high-resolution topography that was gathered at the same time. And so what you get is this 3D view of the crew. Now, the team is actually static, so you don't get to see these folks moving around. That would be pretty intense. But you do see where the 2 crew members are moving around. And so if we run the next video, you'll see all of this unfolding. So the first thing that we have to do is time sync everything precisely. So Ben Feist is using his cell phone clock to time synchronize all of the data sets. Here we are moving around. You can see it's sped up a little bit, but the crew members are being tracked. We have the cameras and drone footage all pulling together at once. And so what's very useful is that eventually with any of the in situ data that's collected, and in a moment you'll see that pop up, you can analyze the XRF data that was collected at that point. Now, XRF data can process, but we can, after the fact, plot it instantaneously. And so we can put exactly at that moment what they were looking at and understand the composition. So this is very valuable as a sort of ongoing analysis tool, but also in evaluating maybe at the end of the day or at the end of the EVA what was collected, what was done, what was analyzed, and how things progressed. So you can plan for the next day or start conducting your scientific analysis, trying to synthesize all of the data. So this support, and then now here's the Station 8, comparable information that's pulled up from XRF. And again, we can place in any of the data after the fact, after it's been collected, to put it, again, not just where it was collected, but when it was collected, so that you can also hear and understand the context of what was going on. So this infrastructure, this support as we scrub forward in time, really kind of enables a different style of analysis. And we've seen with the application of the Apollo17.org website and this approach, a really kind of a profoundly new way of appreciating the work that has been done either 45 years ago or 6 months ago, but then also using it as a tool to identify ways to either improve surface operations or, again, better understand the context of the analyses that are going on. And so whether it's in 5 years, we go back and look at this, where did that XRF point come from and what were the crew doing, we'll have that archived in one location. You don't have to jump to 7 different sites to do that. Let's go to the next slide, please. And that's it. Okay, so I have just a few minutes for questions. Thank you for your time, appreciate it.